Welcome to qnawire.
So they want us to repeat the previous problem, assuming that the pumps and the turbine are isentropic, which is kind of interesting because we're actually simplifying the problem a little bit. And we basically have almost all the information because we had to find the isentropic case to begin with to get the non-isentropic case. So we have pretty much all of the information. Let's see here, 7934. 7934, again, now we have to, yeah, we basically have all the information here. 26, yeah. Anyway, we basically have all the information that we did. So I'm not going to go through all of this because that is just exactly what we did in the previous problem. But now instead of going one step further and using the efficiency to find the enthalpy at 6 and at 7, we don't need to do that. Because it's isentropic, we already have those. And so now we do the same thing, mass energy flow into and out of the feed water heater. And now we get would take an about 18.2% of the steam out of the turbine at 6. We get heat transfer in, heat transfer out at the condenser. So we have a net work of 1,172 kilojoules per kilogram, and that is opposed to, let's see here, about 940. So notice the heat transfer in is the same, it's just that out is different. The mass flow rate is different. We still have a power output of this turbine of 150 megawatts, so we can divide by the specific network out, and that gives us the flow rate, and that's 128 kilograms per second as opposed to 160. So again, because we have, for a given power output of this plant, if we have less efficient devices, we need more flow, which makes sense. Thermal efficiency is now 43% as opposed to 34.5%, which is good. We should expect an increase in the thermal efficiency of the whole cycle. And then we can figure out again, just as we did before, the entropies at all of the entry and exit points of the feed water heater, and figure out the irreversibility associated with that. And in this case, we get 39.0 kilojoules per kilogram, and before we had 39.25. So we have less irreversibility here, slightly less. And again, we would kind of expect that because of the more efficient devices we have here.